So yesterday we looked at rules of exponents. Today we're going to practice those rules again just so you have a chance to better understand these rules. So the goal today is after today you will refine your skills using properties of exponents. You'll also learn how to write a common base. So we'll do some review. We're going to learn one more new thing too. So the warm-up is like what we did yesterday, and it combines several different rules. So the first one, number one, we have 5a to the third times 2a squared. So the rule we learned yesterday is if it has the same base, you add the exponents. But some of these do not have the same base. 5 and 2 are different bases. It's being multiplied, so let's multiply those together. So that's 10. 5 times 2 is 10. Then we look at the a's. We have 3 a's here and 6 a's here. So if we add those together, we have 9 a's. So this answer is 10a to the ninth. Let's look at the next one. There's 3 different bases, the numbers, the x's, and the y's. So let's do the numbers first. 36 divided by 12 is 3. Then look at the x's. We have 7 x's on top and 3 on the bottom. So if you were to write them all out and cancel them, you would have 4 x's left on the top. So this is x to the 4th. And again, to do that, you could write out your 7 x's, your 3 on the bottom, and cancel, and you can see that there's 4 left on the top. We'll do the same thing for the y's. There's 5 y's on top, 2 on bottom, so when you cancel, there's 3 left on the top. So here's the answer for the second one. And again, the rule we looked at yesterday is if it has the same base and it's being divided, you subtract the top exponent minus the bottom. 5 minus 2 is 3, 7 minus 3 is 4. The last rule is if you have a negative exponent, you can flip it and make it positive. So n to the negative 5 was the same as n to the 5th on top. P to the negative 3 will be the same as p to the positive 3 on the bottom. So this is the flip-flop one. If you have a negative exponent, you can flip it and change the sign. Another example, let's say we had 1 over x to the negative 3. You flip-flop it, this becomes x to the 3rd power. Okay. So again, your basic rules of exponents that we spent all day looking at yesterday is same base, being multiplied, you add the exponents. Same base, you're dividing, you subtract top exponent minus bottom. If you have a negative exponent, flip it to make it positive. So if it's negative on the top, flip it to the bottom. If it's negative on the bottom, flip it to the top. If you have 2 different bases to a power, you distribute the power and multiply. And then if you have some number here, again, a power to a power, you multiply those together. Okay, today now the new thing is we're going to look at how can we solve an exponent besides guess and check. So before we do that, let's look at finding a common base for each of these sets of numbers. These are all base 2. This is 2 to the 1st power, this is 2 to the 2nd power, 2 to the 3rd power, and 2 to the 4th power. Base 3, this is 3 to the 1st, 3 to the 2nd, 3 to the 3rd, 3 to the 4th. Base 5, 5 to the 1st, 5 squared, 5 to the 3rd, 5 to the 4th. Okay, so those are all the different bases. And you can do it with any number. We could look at base 4, base 6, and so on. But these are just so you can get an idea of what the different bases are, what they look like. So again, when you have an exponent, 3 to what power is 27? You could use guess and check, and you could plug in numbers here, 3 to the 1st power, 3 to the 2nd, so on, until you get a 27. So we practice this the first few days of exponents, guess and check to solve. But there's another way is we can find a common base. So you look at 3 and 27, and let's go back to our chart. What is a common base for 3 and 27? Well, if you look, 3 is the common base. So let's rewrite using a common base. So this is 3 to the 1st power times x equals, and 27 was 3 to the 3rd power. Now, if 2 things have the common base, and there's an equal sign here, the exponents have to be equal in order for this equal sign to be true. So once you find a common base, you can ignore it, and you can set the exponents equal. So here x is 3, and if you try that in your calculator, 3 to the 3rd power is 27. Let's try this one, 8 to the x and 4. What's a common base for 8 and 4? Well, let's look at our chart. Here's the 4 and here's the 8. So let's rewrite them with a common base. So 8 is the same as 2 to the 3rd power. And we still have this x here. And then if we look at the 4, 4 is 2 to the 2nd power. All right, once we have a common base, since the bases are equal, the exponents have to be equal. So you can ignore the bases, set the exponents equal, and solve. So if we divide each side by 3, x is 2/3. So if you try this, x equals 2/3. If you try this in your calculator, 8 to the 2/3 power, you will get 4. So my calculator's not up, but I'll bring it up so I can show you that 8 to the 2/3 power is 4. Okay, while we wait for that, let's try the next one. We have 9 and 3. Let's find a common base. And if you notice, 9 and 3 are both right here. So let's rewrite with the common base 3. Okay, so 9 is the same as 3 to the 2nd power. And then we'll put the x here. Equals, and the base 3, we don't have to change it. 3 to the x plus 12. All right, the bases are equal, so it must mean the exponents are equal. So we have 2x equals x plus 12. Subtract x from each side. X equals 12. And then again, if you plug in 9 to the 12th power, should equal 3 to the 24th power. If you plug in a 12 plus 12, you get 24. All right, so let me show you how you can check your answer. So that first one right here, 8 to the 2/3 power should be 4. So let's try that. 8 to the power of 2 divided by 3. And you can check your answer, you get 4. Okay, let's try 2 more for a common base. 6 and 36. Let's find a common base here. Let's go back here. 6 and 36. Well, I don't see one for 6 and 36, but I know that 36 equals 6 squared. So 6 could be a common base. So this one I'll rewrite 6 to the x plus 21 equals 6 squared, and then you still have a 2x here, so times 2x. All right, the bases are equal, ignore them. So we have x plus 21 equals 4x minus x from each side. 21 equals 3x divided by 3, x equals 7. And then you can plug in and check to see if both sides are equal. All right, let's try 49 and 343. I don't see it here, but I know that a common base of 49 is 7. So let's try 7 to what power is 343? Let's see if we can get that to work. So 7 squared is 49. How about 7 to the 3rd? Oh, there it is. So 7 is the common base. So this one, 7 squared is 49. And then you have the x plus 3, and I'll put that in parentheses, equals 7 to the 3rd power. And then we have the x minus 7. So there's your common base. Now that you have a common base, ignore the 7s and set the exponents equal. So we have 2 times x plus 3 equals 3 times x minus 7. Let's distribute. So you have 2x plus 6 equals 3x minus 21. Subtract 2x from each side. X plus 6 equals negative 21. Subtract 6 from each side. So x equals negative 27. And again, you could plug in and check your answer. So remember, if you're solving for a variable that's an exponent, you can use guess and check, or you can look for a common base.